Okay, so we're looking at an example of differential equations relating to acceleration and velocity. So here we see that we're given our acceleration function with it's 2t plus 1, and we're given our initial velocity and our initial position. So simply to get to position, we're trying to find the position function. And to do that, we have to take the integral of the velocity function. So we do the integral and we write it out. And then we get this. So 2t, it'd be, there's an imaginary 1, an exponent of 1 here would be plus 2 divided by 2, so 2 divided by 2 is 1, we're left with t, which is t squared, plus, and since this is just 1, we'll add a variable to it, so it'll be t, and plus a constant. This is our constant, it's an arbitrary constant. And so now that we have our velocity function, so we arrived at velocity from acceleration, now we'll plug in the initial position. So we'll set it equal to -7. So at time 0, so sub 0, everywhere we see a t, we're going to put 0. Time 0, the velocity is equal to -7. And when we do this, we put 0 for t here. This turns to 0, this turns to 0. We're left with c1. Now c1 is equal to -7. So -7 is equal to c1. So we found what this constant was. So instead of writing c1 now, we can rewrite this constant as what we know it as, and that's vt. So the exact same equation, but the only difference is, now that we know what c1 is, we'll replace c1 here with -7. And now from the velocity function, we have to take the integral so we can arrive at the position function. So we'll do that again. We'll take the integral of this entire thing, and we'll see here we'll get, so 2 plus 1 is 3, divided by 3, you get 1/3 over times t to the third, plus t, there's an imaginary 1 here, so 1 plus 2 divided by 2, you'll get 1/2 of t to the 2, minus 7, and now since this is a constant, we'll add a variable to it, t, and plus another, because remember we're taking another integral, so we're going to have to write another constant here. We write a constant, and because every time you take an integral you have to write a constant. So here's what we have so far. And now I wrote 4 is equal to c1 here as this constant. So this is equal to, this should be c2 actually. This should be c2 right here. I wrote 4 is equal to c2 already, and I'm guessing you can figure out where that's coming from because we see that initial position is 4. So if we were to just set this equal to 4 wherever, and then t equal to 0, we'll see that this turns to 0, this would be 0 because t is 0, this would be 0 because t is 0, this would be 0 because t is 0, and you'll just be left with c2 is equal to what? 4, because we put 4 here. So 4 is equal to c2. So now we know what this constant is, we know what this constant is. And now finally, we can just rewrite the entire position function as we see here as xt, 1/3 t to the third, 1/2 t to this t squared, minus 7t plus 4, and 4 is what we just found here. So this is the final function that we arrive at after we take two integrals of this function given this information that we have here.